Okay, hello everyone. Yeah, I'm from Warsaw University of Technology in Poland. If someone wants to contact me, you can send email to that address or talk to me after my presentation. So I want to start with, these are the institutions that are supporting me. I want to start with an outline. We are going to talk about tasks in Mars colonization and exploration, the role of telerobotics in that. Next, we will talk about the tools that we have today to perform tasks in a topic of telerobotics. Why do we need new solutions? Because there are some problems that needs to be solved. I will tell about differences between teleoperation and telepresence, how we can solve problems from the fourth point, impact on teleoperations, I mean user interfaces and user experience, and the last will be a summary. So we could start with classification of our tasks. We do not have exact plans for mission to the Mars. We do not know how it will look like, so we have to develop technologies that are flexible and that covers the wide range of topics, of tasks. So once we get to the Mars, we have to build the colony. We would have to build structures like walls to protect against sandstorms, or maybe some caves for special kinds of buildings. And the next main group will be assembling prefabricated constructions, because we would want to save space on our spaceships, whether these are rockets or other inventions. And the next group of tasks will be functioning of the colony, the daily work in that facility. That would consist of exploration. This would be something that we are doing today with our rovers, but we will benefit from the there will be no time delay in control between the operator and a robot. So the efficiency of that operations will be better. We will conduct some research, and we could benefit from the direct supervision of scientists. And the last main group of tasks will be exploitation. That could be the most important from the view of economics, because we want to eventually mine minerals or make fuel on a red planet. And where is the telerobotics in all of that? It's everywhere. In every one of these tasks that I discussed, the telerobotics and robots could provide better efficiency, precision, or at least safety for the astronauts that will be conducting this operation. And our today's interfaces are very simple. We all know these devices. We have we have input devices like keyboards, mice, and joysticks. And today's applications consist just from these blocks. The output devices are displays and speakers. So it's not these are not very advanced technologies, but they are cheap. Everyone knows how to use these devices. But in cases of more complicated machines, like robotic arms or more complicated vehicles than just remotely controlled, for example, car. They are not sufficient and could cause some problems. This is an example of FANUC controller for industrial robots, and this everyone recognizes it. From today's interfaces consist just from these elements. For example, military robots and remotely controlled underwater vehicles are controlled by modified versions of these consoles. As you can see on this picture, this is a control cockpit of a drone. There are many screens that are providing information for the operator, and this could cause mental overload, which could lead to humane errors because of that the operator could quickly become exhausted. And this is a problem that needs to be solved. The drones pilots are complaining about that these interfaces are complicated. The pilots that are conducting operations with drones are complaining about the poor situational awareness of drone operators, which could lead to dangerous situations in which the drone and plane controlled by a human operator could collide, and this could cause serious problems. So we want to improve the situational awareness of the operator by switching from teleoperation to telepresence. Teleoperation is just remotely controlling some devices, for example, like that drone. And telepresence is when the operator feels like he's in a remote site and is doing some kind of work personally. The telepresence technologies are better solutions because they feel more natural for the operator, and this would eliminate the problem of mental overload. So there are new technologies. These are not new technologies in general, because some basic concepts were designed 60 or 70 years ago. So in an era before electronics, but with today's today's electronics, we could use these ideas and make them more beneficial. So first technology that I would want to talk about is haptic feedback. The haptic feedback is, in general, virtual reality for touch. Virtual reality for eyes works like you see something that does not exist and is generated only by a computer, and haptic feedback could you can sense something that is not there. And there are some very interesting examples of the haptic feedback usage. For example, I've read about an interesting research where the ultrasonic sensors were mounted on the size of a mobile robot, and the operator had the information about the closeness of obstacles. So it was harder to pull the joystick in a direction of an obstacle, and it led to better avoidance of obstacles. The haptic feedback technologies were already introduced in, for example, Da Vinci remote surgical robots, and proved to be very useful in that applications. So for the teleoperations in the robots in Mars colony, this will probably also be very useful. The next technology that I want to address will be simulations. There are, for example, we could use the simulations to train the operators and the crew of a colony, which would be cheaper and more efficient, because we could train more people in a shorter time. There is also room for the usage of simulations in teleoperations. There is a paradigm of predictive teleoperation and it is especially useful in teleoperations when the time delay is big. The operator moves the virtual model of a manipulator, and next, when the operation is sufficient and the operator thinks that it's good, the robot would start to do sequence of moves that is pre-programmed. Next thing that I would explain is a pretty simple complex of stereo vision. This is very useful because with one eye, when you are looking at two objects that are at different distances from the observer, you see only one image, and you cannot see anything about the distance between them. But when you have two points of view and you are looking at that object, you can compute some information from these two images, which is very useful, for example, in autonomous vehicles, but also could be very useful in remote operations. This is very simple model of stereo camera. It consists from two simple ordinary USB cameras and PVC frame. When I was testing this camera, I found that I accidentally switched the cameras. So the right camera was sending image to the left eye, and left camera was sending image to the right eye. And my brain very quickly adapted, so I could make some remote operations with the images switched, and it probably has something to do with how our wires are how our brains are wired, because each eye has two axons. One is crossed and one is not crossed, and the occipital lobe is computing the image that could be interpreted. So this is cheap version of Oculus Rift. You just have to put a smartphone inside of it, and here you can see a screenshot from a smartphone. This is image from left camera and from right. So you can see the workspace in 3 dimensions. And the preliminary tests showed that the operational capability of a user that is equipped with stereo vision is much higher than the user without this stereo vision. So the impact on user interfaces, user experience and safety from these technologies will be that the systems will be easier to control, will require less training, and it will be possible to accomplish more precise and complex tasks because the interface would feel more natural for the operator. Yeah, so to sum up, our requirement is to carry out some tasks. We have some tools to do these tasks, but we have some problems with them. And today there are some tools in development and we could benefit from these technologies. For example, in operations on Mars, but also on Earth. For example, in medical applications and search and rescue robots. So if anyone have any questions. Yes?
In terms, so for perception, what I heard you say was perhaps use three-dimensional imaging to assist in that. And on the other part, maybe for reaching for things, have you considered use of things like motion capture operator being outfitted with a suit with reflectors on his or her arms and actually reaching for an object and having that motion translated into a motion of a robot, which would be much more natural than
Yes, yes.
joystick.
There are technologies like that in development. And you could also use, for example, Kinect camera and analyze the movement of the operator.
Thank you.
Okay, thank you.